So, thank you very much, everyone, for being here. Our session today is devoted to the vacuum of quantum field theory and the Protean daemon of analogy. It is a session devoted to the history of physics, but of course there will be some conceptual underpinning that are philosophical in nature that will be discussed today. I'm very, very pleased to introduce our speakers today, Rocco Gaudenzi and Stefano Furlan. They are both postdocs. They work at the Max Planck Institute for the History of Science in Berlin. Now I will leave to them the scene and the discussion. Thank you very much for accepting this invitation.
Thank you very much, Silvia. I'm very, very pleased to be here and have a chance to speak about essentially what is a work that I've started some years ago, and then Stefano joined, and we kind of went together on developing it quite further. So yeah, so as you see from the title, there is analogy, there is vacuum quantum field theory, there is multiform demons and so on. So I mean, it's gonna be somewhat articulated sometimes in the physics a little bit, perhaps sometimes, but I would say that so the idea that I had is this is the first part one I do, and then Stefano does the second part, and basically structure in the way that I'm gonna give a little bit of an overview and then try to go into the details, but not much of one of the cases, the historical case studies that we have taken our main paradigms for this, and then Stefano is gonna do the second one, which is on John Wheeler. So okay, so I guess I start. Okay, yeah. Do you see the slides? Yeah. Okay. Yes. So what we are trying. We're trying to do here, and also in a paper that now is been submitted, and you will be able to read it at some point soon, I guess. It is to find a methodological framework for grafting the historical and heuristic complexity of analogical reasoning into what is somehow of a philosophical analysis that already exists. Such an analysis of analogy, I would say rather pretty much from antiquity to today, with some exceptions, of course, that we might discuss about, but not many, has mostly treated analogy as a form of logical inference. So such analysis yield, I would say, what we have called the retrospective and point-like account of analogy. What do we mean by that? In a sense, well, these accounts are valuable in the categorization of the modes of analogical inference and the assessment of the logical strength of the argument, the logical gain, and so on and so forth. But they have these two sort of shortcomings, in a sense, limitations that are related to the retrospective and point-like character, which are the fact that essentially these accounts reduce analogical thinking to one of the possible outcomes, in fact. By this we mean, for example, I don't know, two-column table, by unequivocal correspondences, vertical, horizontal type of analogy, this kind of schemes which have a clear outcome, and which it's considered as an endpoint of the analogical reasoning. So some sort of like the final result of it, no? So what these accounts have done, they kind of tend to reduce the whole thinking process to one of these possible outcomes, rather than considering it as a dynamical process that it is, with various other implications on the way. And also, I would say the other point is that it doesn't capture the thinking process that, in a sense, produces these outcomes in the first place, and the functions that accompanies this thinking. So okay. Now the purpose here of our framework and the talk here is to instead, like on the contrary, in a sense, in contrast to that, provide this more of a prospective, what I say, a prospective and durative account of the analogy. Prospective in what sense? But in the sense that as much as possible, it is from the standpoint of the maker, so the viewpoint of the maker, the person, the scientist, and so on, who is involved in the analogy, who does one of the steps of the analogy or the whole of it. And in a sense, it answers the question: how could one get to that certain outcome if there is such a clear outcome? Because oftentimes there is not such a clear outcome that you can say, well, okay, this is it, this is the reference point, but it's more of a complicated process. In any case, how one gets there goes about in the process. And the durative aspect is somehow the historical, the properly historical one, that all the processes, like there are many processes in the analogies that are durative, that take time and they involve a transformation and evolution. These processes are like the preparation of the domains, because analogy doesn't come out of nowhere like that, but it needs a preparation, needs a formulation of the domains, and then the triggers. There are certain triggers that trigger the process, and then also on what follows the analogy. This is what precedes what follows the analogies are the long-term consequences of the outcome of the analogy. So in a sense, I again say in the motivation is analogy versus analogical reasoning, because one can say very simply that the reasoning is this longer process, whereas which you should be able to treat historically, while the philosophical accounts are often like on the analogy as the cognitive point-like act. No, so everything, it looks like it's concentrated there, and nothing precedes, nothing follows that, and it comes out essentially out of nowhere. So that's why there is this contrast that I make there. So now, from our methodological standpoint, how we have went about in doing that, well, the idea is that there is a connection with the heuristic practices and strategies, that this is an essential element, and one sort of constructs these kind of frameworks, drawing from these practices and the role that analogical reasoning has in these practices, from studying what it calls, in a sense, the empirical material, which is the mostly archival material and published material and so on. And also in the long durée, it's important because otherwise, again, one tends to isolate certain parts, and whereas the analogy, again, if you study in the long durée certain cases, you really see that it's a process that can go on for decades. So it is important to kind of that's where it starts from. What one draws the framework from, all these elements from. So I guess I'll skip the objection. I'll just go through it very quickly. So the idea is that, so what if one can say, well, if we add the historical dimension to this ahistorical aspect that the philosophical analysis in fact tries to distill, we end up with something which is too idiosyncratic to be of general interest. So say there is a certain moment, certain cognitive act that is hard to understand because it's too personal, it's too idiosyncratic, and so on and so forth. That's certainly true. But what we and we would say every historical event is an event in itself in a certain sense, so therefore idiosyncratic. But the process of constructing the analogy, in a sense, remains a very rational and reconstructible process that can be understood. So in a sense, if only specific moments, turns, cognitive acts that cannot be understood because they are too personal, but all the rest, in fact, can be reconstructed. And of course, the underlying belief and the assumption of such a framework is that this is comprehensible, such process. So now, in a sense, the base of the framework is to understand that in the practice of scientific reasoning, analogy simply operates without what I call the pressure, if you wish, or the constraint of that a logical inference would have. And this lies, in fact, really in the heuristic context itself. I mean, we could say heuristic work most often, in fact, does not proceed judging the truth or falsity at each step, but in fact it operates at a level where this dichotomy is suspended. You know, we don't want to, we don't, the moment we create something or the moment we go about and trying to clarify something, we don't use that category of truth and falsity at each step of our reasoning. And you can say it in another way, a little bit more like iconistic, is in the discovery process, the end justifies the means. So the means do not need to strictly be false, true, or wrong or right. There is not such much of that thing, but it is the end that then in case needs to be verified as true or false. So now in this situation, the analogy, you can regard it as a means to produce representations, if you wish, redescriptions of something that is as yet unknown. It's an unknown domain that you want to approach in a certain sense, and one of the ways is to produce is to make analogies. And so the representations as any representations, in fact, are not true or false. It's not a matter of truth or falsity, but it is they are always hypothetical in a certain sense, and they are instructive in various degrees. So that's how you measure. So they are appropriate or non-appropriate to a certain purpose. Okay. So as I said before, the judgment on the true or falsity, in a sense, the empirical adequacy comes after. It is something comes after, and it is done, in fact, by other means other than this, the means of speculative reasoning that are involved in the analogy. So now, how can you? So the idea to capture, in a sense, these other aspects, so the more heuristic and the context of discovery aspect of analogy from an historical philosophical point of view, in a sense, we shall in fact consider analogical reasoning as it is disconnected from a judgment on the truth value of the hypothesis it produces, it makes, and the question is how. I would say that, I mean, I think one viable way is to consider the analogy from the hermeneutic and cognitive standpoints, rather than from the logical, strictly logical standpoint. And in fact, the tools exist. This can be done, I say it's best done, in a sense, employing the conceptual tools that have been used to frame metaphor so far. So then if you regard analogy as in fact sort of a subcategory of metaphor, where the terms are specified more precisely, the correspondences are sharper, both analogies and metaphors are forms of artistic or scientific representation in general, no? So through them we represent a certain target, a target reality, domain, or an object, whatever you wish, by means of a source domain that we have recognized as similar in few respects to the target, while being dissimilar in all the others. So as to quote Aristotle, the metaphors and analogy are based on recognizing the similar in the dissimilar, in the otherwise dissimilar. So now the cognitive gain of this act comes from the fact that the structure, which is just a general way to say a property or an attribute or a relation between the parts of this domain or this object, and that the structure of the source domain is already known to us, or it is more evident than it is the structure of the target domain. So we can use one as a blueprint of the other, as a paradigm of the other, and to clarify what is somehow unknown. So now the representations, then these representations are judged, in fact, both artistically and scientifically, it looks like there's not much of a difference, are judged as more or less appropriate to extract and identify what in a target domain as hitherto at some point remained implicit or hidden. Okay, that's how they serve. So I'll give some examples, just very briefly, just to give you an idea. So the similarities within the dissimilar, on which we can leverage to represent an object by means of another, as we know, can be material, formal, structural, and actually most of the times they are mixed, intermingled, these different categories. And it can be more generic, visual, or have more formal purposes. So, I mean, we can say metaphor representations of like the river of time or time flows, or the popular liquid society by Bauman, the dendritic structure, which is like a tree-like structure, or the leg of a chair, or so on. There's, of course, many innumerable of these expressions that we use even like a lot on the daily basis. Then we can go a little bit more scientific, and we can say black hole by Wheeler. Stefano is going to say something about this. The idea of electric current, again, it's joins and juxtaposes the electricity with something that normally belongs to the domain of water. The analogy that atoms behave like rigid balls, it's Boltzmann is at the base of the kinetic theory of gas, and to regard the thermodynamic behavior from a microscopic perspective. Or you can say atoms are planetary system when regarded when you regard electrons are as orbiting in a sense, or within their relationship with the nucleus. And rather in the same way, I mean, in the different representation, electrons are waves, as we know from the speculation of Schrödinger, for example. So on another line, you can say the brain as a computer. This is, of course, an analogy that serves the functionalist approach to the brain and mind. And the meson is a photon with a mass. This is Yukawa. And then there are two that we sort of now we will elaborate a little bit on. So this is the vacuum of the universe is a solid, is in fact a superconductor according to Yoichiro Nambu, or say a rock formation in the sense that has geological layers according to Wheeler. Of course, Stefano will speak about it more extensively. This is just to give you an idea of the processes of the representational processes that are involved in analogies and metaphors in similar ways. So what one can say is that in fact none of these analogies wants to exhaust the content of the target domain. But what it does, it provides a representation of it at certain angles. It every time isolates an aspect while forgetting others. So now we go on to some functions of the analogical reasoning based on what we said. We kind of make it a little bit more precise. So in all these cases, the cases that we have mentioned, but many others, analogy was a tool to organize, order, inform, always in an hypothetical way, in a provisional way. So, on the basis of some source domain, a target domain of phenomena, as a set of phenomena whose connections were not a priori evident. Okay, so the domain that is subject to the analogy with this operation takes a certain direction, and certain aspects of it are temporally isolated, made visible, while others are forgotten or go to the background. So now, regardless of the fact that the direction might be not definitive, not final, and in fact, oftentimes that's the point. It is only analogies are only intermediate steps. So again, these outcomes are all intermediate, are just stepping stones, if you wish, within the heuristic processes. So regardless of these, that they might be intermediate and actually turn to be wrong at some point after, if you wish. So the model, the outcomes are that are outcomes of the might be wrong and so on. Nonetheless, this analogy has taken us from a situation of disorientation before a domain of phenomena to a condition in which we look at it from a specific angle. So we take truly a perspective, and okay, on that a perspective. So this angle that we take, or direction, if you wish, gives a relevance and hierarchy where there was arbitrariness at the beginning, and informs and conditions then the evolution of thinking. Okay, So again, it's not a verification tool, the analogy, but this is a later stage that occurs when in a sense, that happens on the model or on the theory that the analogy has helped generating, okay? And in fact, this is pretty much always an independent experimental verification, especially in experimental sciences, of course, and that have this possibility. And this in fact, takes place by other means that are not the ones of analogy. So now we can kind of restate what we said in a concise way. So analogical reasoning as a process is one of the main processes to generate working hypotheses, and therefore it is quintessential to the heuristic phase, where the attempt is to orient and organize the material of a target domain. It is to advance its understanding through a comparison with something known, and not rigorously prove such hypothesis, okay? And also analogical reasoning is characterized again by not being logically true or false, but more or less appropriate for a purpose of illuminating a situation at hand, okay? It should be judged then on how much it makes visible and instructs us on how to formulate or solve an open problem. And here instruct, I use it in a double sense of giving us a certain instructions and teaching us something, okay? So these, in fact, these processes are durative, have a certain duration, and these are the ones that, when tracked, open up this historical dimension. Okay, so and I want to give an illustration of these points by way of an example, and then I'll add a few more points that are more evident from this example. So now this might be a little bit complicated, but I mean, we can try to make it simple. So this concerns this process that goes roughly from the 1930 to the 1960 that culminates with the discovery of the spontaneous symmetry breaking by this Japanese physicist Yoichiro Nambu. Okay, so now the whole kind of reasoning, if you wish, starts from resuming an hypothesis that was Dirac, and Dirac proposed in 1930. So if you look at the picture there, you have. So the idea is that Dirac, when working on the electron theory, the relativistic electron, did discover that, in a sense, or let's say, pictured the vacuum of quantum field theory as analogous to a Fermi gas. So the vacuum is not anymore like an empty, truly like literally a vacuum, but it resembles more like a plenum, and as the structure of a Fermi gas. So is the light gray that you see there in the cartoon. So in a sense, the vacuum from minus infinity to zero is filled with negative energy particles. Okay, so this, of course, as you know, it was just dismissed very soon after, because as immense problems with infinite amount of charge and so on and so forth, and the fact that you don't observe this charge and so on. So this vacuum that was supposed to be filled with negative energy electron is just, in a sense, dropped and surpassed. In fact, so the analogy serves, but it is surpassed by the quantum electrodynamics, who then just dismisses this idea and says, well, there are creation and annihilation operators, and we don't need such contrived type of picture in order to be able to explain some phenomena. But this doesn't matter much. So now, 20 years later, Nambu in 1950, on the basis of the Dirac hypothesis, I mean, it kind of resumes this hypothesis, it revivifies it, and says, well, okay, well, why don't we consider the vacuum as Dirac has done, and then we add, and we consider then the solids, solid media that are this gray, dark gray, as something that is a continuation of this vacuum. So in a sense, it draws an analogy between the Dirac's vacuum and the solid media. Okay. So the Nambu's reasoning is the following. So if the vacuum, as Dirac has hypothesized, behaves similar to a solid as a structure of a Fermi gas, then one can think of the solid as a material extension of the vacuum. In fact, he calls it an apparent vacuum. So you see clearly the analogy. So the solid becomes an apparent vacuum, and what is the purpose? Nambu reconsiders Dirac's analogy but for a different purpose than Dirac, and then, namely, is to actually formalize the solids, to construct the theory of solids with the tools of quantum electrodynamics. So you see, something was judged unphysical, false, if you wish, as something that truly couldn't exist, is then resumed years later, suspending that judgment, and with another purpose. Okay, so the analogy has already quite an historical dimension, as you see. So now, what Nambu does in the decade between 50 and 60 is it builds on this basis a field theory for many body systems, and then he analyzes, he examines and then reformulates plasmas with that in 54 and superconductors in 59. This is a very important work in 59 because it discovers this phenomenon of spontaneous symmetry breaking happens in superconductors. I mean, it doesn't matter much the details of that, but the point is that once he has understood and formulated the behavior of the superconducting solid, where he sees in the language of field theory, he sees this, he realizes a phenomenon, an important phenomenon, and then in the year later, he realizes that actually that phenomenon happens, it takes place in an analogous way in the vacuum itself. So we can say the phenomenon we are discovering superconducting solid turned out to be at work also in the quantum vacuum itself. So it does shape the quantum vacuum in a certain way and helps understanding a phenomenon that would be otherwise invisible and implicit in the vacuum of field theory. So now the point here to emphasize is that this whole process from 30 to 60 based on a single analogy, which is Dirac, the domain of solids, of solid state physics and of the behavior of solids had acted as a source, first with Dirac, and not to illuminate, to formalize the vacuum of field theory, and then with Nambu 20 years later, first as a target and then again as a source domain at every step of this process, making visible in the respective target domain something that was remained invisible. Now, here there is one other aspect that is clearly emerging from this type of analysis of analogies is that this is, as I said, what we Stefano and me, that's inspired by von Hofmannsthal, the writer you might know, we have called the allomatic character. So analogies are, in a sense, rarely a one-shot process, but rather mutually transform over time the involved domains, as you see in an alternate and reciprocal way, and also the maker, because Nambu gained a knowledge that then allowed him to discover something at the end of this long chain of analogies. Okay, so now from that we can, so from this case we can draw some other features, this sort of durative feature of analogical reasoning. I mean, the first we have just said, allomatic, and then there are two others that I try to kind of wrap up quickly. The fact is what we call representation dependence or representation sensitiveness, in the sense that especially when formal analogies, the way the domain, the target or the source domain are formulated, the mathematical shape, the formal shape that they take, is key to then make an analogy. So an analogy is visible perhaps only whether there have been some kind of formulation, whether there have been some steps. Okay, so one case is, for example, in the Nambu's case, to analogize the vacuum, so the vacuum of field theory to a superconductor, you actually need to formalize the superconductor with the tools of quantum field theory. Otherwise, you wouldn't see the possible analogy. There is just not enough elements to see the correspondence. Okay, so there is a construction of the domains that really has this historical dimension, which is very important. Again, an analogy doesn't come out of nowhere, but often is a result of a long preparation. And so this is the representation dependence, but it also means in a sense on the flip side of the coin that analogy depends also on the eye of the beholder, and of course you include therein a certain personal experience, a certain accumulation, which as a historian you should track, the parallax effects, and idiosyncrasies of many kinds. So these are the more personal elements that to be included in this historical in this historical philosophical framework of analogies. And the last feature that we sort of identified is the fact that, as you see in Dirac, there was analogies are often tools that allow the construction of abstract scientific concepts by means of a concrete analog. Okay, so and they do by selectively transferring properties of this concrete analog to the more concrete in order to kind of construct it. Okay, so this is so represent the concrete, the abstract by means of the concrete. And the case of Dirac is obvious because the vacuum that is a more abstract construction entity then is a kind of looked at through the concrete, the Fermi gas, the solid, and in order to be able to formalize it and understanding. Okay, so actually, if you look at Dirac's process, so the first there is a concrete analog, and then this is used to build something, and then this concrete analog is forgotten, is actually judged as unphysical, and so on and so forth. Now, what Nambu does is to recover this concrete reference, okay, and rediscuss it, reuse it in a different light. Okay, so you can regard the process of this kind of this effacement of the concrete analog, but then also occasionally the resurgence of the concrete abstract, the concrete analog, and the reconsideration in another light. So with this, I'm finished on my part. So as I said, you might want to, perhaps if you are interested, look at these three references where we kind of elaborate different aspects of what we said. And then for the rest, if there are no questions, I leave the floor to Stefano. Wait.
Yes, I think you just have to stop sharing.
Yeah. Sorry, just yeah.
And now Stefano can go ahead.
Yeah.
Thank you.
Okay. Do you see the slides? Okay.
Yes.
So thank you again for being here. Thank you, Silvia, for the invitation. So first of all, I would like to show you a two-column table and a picture. The table comes from the 1957 seminal paper in which Wheeler went public about his expectations and long-term aims of instrumental dynamics. This is also the standard reference for the introduction of the so-called quantum foam, even if in Wheeler's private notebooks there is trace of it a couple of years earlier. I'm going to tell you a few things about quantum foam and specify better some of the terms I've just used. But for now, let's consider these two pictures. The table may look quite cryptic. Indeed, Wheeler does not use a new terminology for the highly speculative ideas he is suggesting, such as an electron as a cloud of geometrical fluctuations. He resorts instead to a seemingly innocent expression, such as electron physics. Then he puts in there some number, which has the air of being soberly empirical, and then invokes a suggested parallelism between superconductivity and his own pan-geometrical view, in which particles are made out of pure geometry. Now, more than 60 years later, we know that this analogy did not lead anywhere. If you try to figure out this analogy as if it were indeed a four-term proportion, according to the Greek meaning of analogia, no matter how familiar you are with Hamiltonians or mathematical details of the theory of superconductivity, you could not precisely pinpoint what Wheeler was talking about. The reason is the following, and it requires a very different hermeneutical move. Let's notice that the year 57 is a crucial one for superconductivity, both for the BCS theory and for Bogolyubov's contributions. This is an important remark, because Wheeler is subtly making leverage, a rhetorical leverage, on the fact that there was this intriguing research field at the frontiers of physics, superconductivity, whose understanding was making progress, but at the same time was still surrounded by an aura of fascination and mystery. And then there was Wheeler's own visionary attempts, still lacking in technical details and so on. The phenomenon of superconductivity displayed a mechanism capable of accounting for the disparity of orders of magnitudes, such as the one in the right column of the table. What Wheeler was suggesting, with the enthusiasm of new developments being on the verge of happening, was that a similar hypothetical mechanism, perhaps, could also account for the disparity he was finding in his own geometrodynamical attempts. And perhaps one day there would be a powerful and beautiful theory capable of accounting for both these problems at the frontiers of physics. This analogy is not at all a given bionivocal correspondence. It is just the suggestion that one mystery could shed light on another, perhaps in an allomatic fashion, we could say. Or, to put it bluntly, that one day there might be some mathematical language capable of removing these problems from Wheeler ideas, of which he was evidently very convinced, problems notwithstanding. But it is not a coincidence that after the theory of superconductivity got well established, and in a sense lost part of that aura of mystery, which could leave room for ambiguity and for procrastination, Wheeler's insistence on this analogy disappeared as well. I think this is a clear case in which the rhetorical, but also explorative dimension of analogies is simply evident, and it would be very naive just to dismiss it as a mistake. Likewise, on the right, you can see, 10 years later, how Wheeler was resorting to some cutting-edge microscopic photography to persuade people about his ideas about quantum foam. Here, in a sense, we have some visual analogy as well as a visual rhetoric. Obviously, even if you can show people that this picture is somehow faithful at some small scale, that does not imply at all that the same holds some 20 order of magnitude shorter, near Planck length. It would be foolish, however, to assume that someone like Wheeler did not know all that, and to point out that there is here a non sequitur or a logical mistake. We could go on for at least a couple of days with similar examples from Wheeler's papers. Here, you can have a taste of an unusually schematic page of his private notebooks. As you can see, the Protean demon of analogy of our title is not entirely out of place. But let's try to make some more organic considerations. I will offer you an example of how a powerfully analogical guiding idea, that of quantum foam, could not only prompt people to invest in directions of research which were and are well beyond empirical confrontation, but also how this guiding idea could even enter into conflict with the technical formalism that was being developed to accommodate this very same idea. Contrary to an oversimplified story, Wheeler, from deep analogies by thought supplied, to borrow a line from William Wordsworth, abandoned the formalism, the Wittian quantum gravity, we could say, instead of his guiding idea. Of course, that is not to mention Wheeler as a role model or to induce some approval of his modus operandi. But if we just back project some abstract notion or cliché, and we ignore the actual historical documents of such an impactful figure, the resulting picture gets heavily distorted and is also made quite poor, and we just keep repeating some superficial and pseudo-technical assumptions. So let me start these considerations with a quote from Theodor Adorno, first lesson of his philosophical terminology. Quote, "The task of philosophical treatment of terminology can only be that of resurrecting the conceptual life that coagulated in words." End quote. We have touched upon this issue in the paper, as you already heard from Rocco, but using different references. Now, we do not intend to adopt the overabused phrase archaeology of, but of course, the stratification of meanings and connotations that get encapsulated in words that is, the historical dimension of words, is a point we have stressed. With a beautiful sentence by the eminent philologist Giorgio Pasquali, we may say, the world is like the water of a stream that carries with itself the flavors of the rock from which it gushes and of the lands through which it has passed, end quote. But we have as well underscored, as you have just heard, the ability of some analogy to re-exhume some previous layer that had become dead metaphor, something we do not react any longer to. Such an example, even in the exotic realms of theoretical physics, is offered by Wheeler's sketchy phrases and expressions, with their visual and concrete vividness. Think of black hole. It doesn't matter whether he actually coined it or he just adopted it. Another one is indeed quantum foam, a nice example of the elusive function of naming, even of scientific naming, as is often implicit in metaphors and analogies. As Mark Twain put it, quoted by Wheeler himself, the difference between the almost right word and the right word is really a large matter. It is the difference between the lightning bug and the lightning, end quote. Quantum foam was definitely the right expression to convey Wheeler's ideas about the breaking of phase smoothness near Planck length, but actually hides much more in a story which covers decades of Wheeler's long career. At the beginning of the 50s, Wheeler underwent a sort of conversion that, from nuclear physicist lato sensu, led him to become one of the main figures in the general relativity community. Everything is geometry became his slogan of that period. Geometrodynamics became the name he gave to his own program. One of the programmatic papers of geometrodynamics, Misner, Wheeler, Classical Physics as Geometry, 1957, has as a subtitle, quite significantly, gravitation, electromagnetism, unquantized charge, and mass as properties of curved empty space. We can see, however, that such an attempt at geometrizing all those basic features of the universe just in terms of empty space was classical in its outlook, as that unquantized makes explicit. Still, the idea of moving beyond that was already at work. In fact, if Wheeler was personally close to Einstein, he was also close to Bohr. Far from sharing Einstein's rejection of quantum mechanics, he tried over and over to conciliate the legacies of his two inspiring figures. This, of course, is the still open challenge of quantum gravity. In the other 57 paper that I mentioned in the beginning, there is a reference to the energetic balance of the vacuum, problem which was given a sort of pedigree through a typically Wheelerian use of history by underlining that Niels Bohr had thought a great deal about it. But of course, Bohr's concern, as quoted by Wheeler, had been about the energetic balance of the Dirac sea, while Wheeler, in his work, was dealing with the empty space of general relativity, qualitatively assumed to have quantum fluctuations near Planck length and properties akin to the vacuum of quantum field theory. In short, by the late 50s or early 60s, Wheeler had new and different tools from Bohr's. The fact that he appealed to Bohr himself, struggling with the Dirac sea, serves mainly the function of grounding his ideas and alluding to the past vicissitudes of a complex and in some regards elusive notion, that of vacuum, with its problematic energy balance and its quantum fluctuations. Since the Dirac sea was an important starting point for Nambu too, as we had seen, the confrontation between the two can nicely show how focusing on some traits of a concept instead of others can lead to developments in very different directions. So the focus here, as I've already repeated, is on quantum foam. Qualitatively speaking, the guiding idea or expectation is relatively simple. The basic substance, if it may be called like that, from which Wheeler was trying to build everything, was not, at Planck scale, smooth as marble, as classical geometry, but rather similar to a boiling liquid. This is due to quantum fluctuations of geometry itself, or even more strongly, different possible geometries interfere. It is important to understand that, contrary to some no less qualitative usage of nowadays, by quantum foam, Wheeler did not just mean some sort of space-time granularity. In the early 60s, quantum foam became pivotal in the strategy invoked by Wheeler for singularity avoidance during his still problematic engagement with gravitational collapse and black holes, still ante litteram. This is a part of a not so linear story, only recently reconstructed in its different dimension, and I redirect you to another work. I'm sorry for this self-advertising, but it's not my fault. A story, I was saying, that led Wheeler from an initial skepticism or even hostility towards Oppenheimer and Snyder's pioneering results, to later becoming the enthusiastic godfather of black holes. When he abandoned his first reservations, Wheeler was still disturbed by the issue of the central singularity of black holes, where infinite quantities were supposed to appear. Judging them unphysical, he believed instead that the effects associable to quantum foam in proximity of a singularity could play a crucial role in singularity avoidance. How come? The black hole, tying together large-scale and extremely small-scale issues, such as, respectively, the collapse of massive enough stars and distances nearby Planck length, offered Wheeler a uniquely insightful model to understand the origin and ultimate destiny of the universe, or so he believed. In the 67 Bataille Encountre, he resorted once again to an analogy to illustrate the coupling he was envisaging between gravitational collapse and quantum foam, a waterfall and the foam it produces. At the level of imagery, incidentally, it is quite reminiscent of Kolmogorov's theory of turbulence, if someone is familiar with it, with that sort of waterfall effect scale by scale, but just at the level of some evoke picture, of course. The arena envisioned by Wheeler in order to treat these issues and to express his ideas was a so-called superspace whose points represented possible geometries of the universe. A line in this superspace is then the story of a universe whose geometry is evolving as first shown by general relativity. Introducing in this arena quantum physics, more specifically an uncertainty in superspace, which is supposed to be analogous to the one in position space related to Heisenberg's principle, Wheeler tried to transfer the basic features of the quantum into the new formalism he was developing, thus introducing a wave function for the whole universe. And that meant that there are spread probabilities for the state of the universe itself. Approaching the Big Bang or the Big Crunch, the storyline of the universe ceases to be a line, with quantum foam possibilities interfering and getting inextricably intertwined, and common sense questions such as what happens next, what happened earlier, losing any meaning. In this way, the core of indeterminacy of quantum mechanics got tentatively, and by analogy, extended to the very history of the universe, with the result of losing time ordering. All that, of course, was something highly speculative. If that was not enough, Wheeler started presenting quantum foam very qualitatively as the ubiquitous gravitational analog of the Lamb shift, which had been so important in the genesis of quantum electrodynamics, and this well-known importance, obviously, played a role again in the rhetorical dimension of the analogy. By analog, he only meant that we are supposedly dealing with vacuum fluctuations of a different kind, electromagnetic in the case of the Lamb shift, gravitational in that of quantum foam. Paradoxically, then, the vacuum was thus getting charged with more and more properties. Speculations notwithstanding, physicists that nowadays are still working on these topics, at least in some quantum gravity approaches, when they refer to the old papers, tend, as unfortunately quite typical, to cover historical superficiality with technical jargon, thus inducing back projections and linearizations when not trivializations of Wheeler's evolving thoughts. In this way, while speaking of these matters, they ignore or do not realize the tension between Wheeler's idea of quantum foam, not today's generic version, and his own superspace. Far from being just details to be left to historians, this tension would, in fact, ultimately explode, at least in Wheeler's mind, because his superspace arena turned out to be inadequate to represent the topological fluctuations which were central to his idea of quantum foam. You have seen in the very first picture that the boiling quantum foam leads to the formation of handles and wormholes. That means that the topology of the manifold, that is space itself, changes, and the machinery of geometrodynamics did not seem capable to account for that. By the early 70s, Wheeler ended up being convinced that everything is geometry program sorry, could not be enough, nor could his geometrodynamical vision aspire to have the last word. He was thus prompted to look for a pre-geometrical, deeper level from which space-time itself was somehow supposed to emerge, ambitious and problematic idea pursued to this day. In the following years, Wheeler looked for inspiration from logic, from other mathematical realms, from ancient and modern philosophy, Leibniz in particular, and I redirect you to another work, but also Spinoza and Schelling, from biology, biophysics, informatics, until in the end he reached his famous it from bit perspective. An interesting dialogue occurred from the 70s on with Ilya Prigogine. Unfortunately, there is not enough time to enter into detail, and I have to conclude. I redirect you to this paper here with Alexander Bloom for something more. I just want to say that the relation between Wheeler and Prigogine is a very intriguing and rich one, even though it is almost entirely unexplored. Part of the reason, I believe, is that it is based on unpublished archival material, but also because the way of approaching the ideas of scientific thinkers is often lacking a serious confrontation with the actual historical working notes, especially in cases like Prigogine, who has become, in a sense, a prisoner of the bunch of slogans that he himself, together with Isabel Stengers, of course, created in order to convey his ideas to the public at large. And to be honest, the variants of all the different editions and translations of his books are quite a mess. A Prigogine anecdotics is not an immediate task, even if the core ideas stay the same. Just some bullet points then. Two of the main foci of Wheeler's and Prigogine's discussions are the role of the observer, in the wake of quantum physics, of course, and time. What Prigogine found in far from equilibrium thermodynamics correspond, the analogy is theirs, to the consequences opened in front of Wheeler by the unstoppable gravitational collapse. Prigogine's refusal of a geometrized or merely parametric notion of time in favor of its Bergsonian creativity is mirrored in Wheeler's biophysical inspirations during the 70s. I could also mention his dialogue with Manfred Eigen, and his search for self-organizing processes, possibly responsible even from the emergence of space-time itself. We don't have to forget that, at least in Wheeler's eye, the inadequacy of the traditional notion of physical time was a result proven by its geometrodynamics. In terms of general outlook, both Prigogine and Wheeler would try to develop a new worldview, widely extrapolating their physical researches, but trying to offer a new picture of the universe as home for man, La Nouvelle Alliance, and so on. The basis was for both a crucial role assigned to fluctuations. In a sense, the reaction to Jacques Monod and the worldview expressed in Les Hasards de la Nécessité is a battle for the meaning of fluctuations. In a classical picture like Monod's, fluctuations are deviations from a given order, and if our existence is somehow a consequence of fluctuations, that is a further proof that it has no meaning, and that we are existentialistically thrown in the silent immensities of the universe. In Prigogine's and Wheeler's view, fluctuations are not deviations from a given order, but an intrinsic quantum feature of everything, and the basis of any gradually built order out of chaos, or with an even more explicit expression by Prigogine, l'ordre par fluctuation. And in this growing complexity, life is no longer made appear as a meaningless accident. The observer is participant, and so on. In general, I would say that the reconstruction of the Wheeler-Prigogine dialogue is also an application of analogy as a historical tool, as we have also outlined in another work, in which we have examined some affinities taking place in Dubna between Pontecorvo's earlier idea about neutrino oscillations, not yet flavor oscillations, and Bogolyubov's theory of superconductivity. Anyway, to conclude, in all the dialogues that from the 70s on, Wheeler tried to establish with different fields, he employed, as usual, his peculiar and exuberant communicative style to sell his ideas, or at least to give it a vivid pictorial, analogical representation of what he was trying to express. This would lead to another story. Still, in order to see how, by then, he could look with new eyes at the issue from which we started chronologically, the vacuum and the Dirac sea, we can listen to Wheeler's own words about the surface geology and underground geology of the vacuum. Quote, "The student who first takes up geology finds no feature of the landscape more interesting than its topography. Later, he sees cores drilled out from widely separated locations with identical strata. He comes to think of the stratum as the primary concept. Finally, he begins to appreciate that underground strata and surface topography are manifestations of one and the same dynamic geology. To the student who first learns about relativity, no feature of the vacuum attests more clearly its power to take part in physics than in its curvature. And then, of course, there will be other strata, such as the pre-geometry Wheeler was looking for. Quite significantly, we may now add, in the end, that after following all this path of his, it is meaningful that Wheeler chose the following 3 lines by Thomas Stern Eliot as epigraph of his paper. The end of all our exploring will be to arrive where we started and know the place for the first time. Thank you.
So thank you very much to both Stefano and Rocco. It was an extremely rich and complex talk. Well, 2 talks into one. So it's now time for the Q&A. As usual, I ask people to raise their hands through the app or to write, that you want to ask a question or make a comment by using the chat. So we can continue with the discussion. Are there comments, questions? Well, actually, I can start in the sense that there is a reason why I invited you guys today. It has to do also with the fact that I know that you both worked on analogical reasoning, analogy. So I met Rocco for the first time in 2018 at a conference on analogical reasoning. Plus, I became acquainted with your recent work with Stefano and on Wheeler, and specifically my group and I are interested in Wheeler's work, albeit indirectly, in the sense that most of my collaborators don't work on Wheeler specifically. But Wheeler is the father of this concept of geometrogenesis. And as you know, the concept of geometrogenesis is extremely important in group field theory, which is one of the approaches that we investigate in theoretical physics in our group. So for me today, it was very, very intriguing to see how 2 different topics that we treated separately in our discussions in the research team have been put together in a very clear and exhaustive way. I have a question, first question for Stefano. So Stefano, in the penultimate slide of your presentation, I don't know if you can resume the slides. Okay, so if you go back.
This one?
Okay, yes, here. So you mentioned this from relativity to mutability. So you mentioned this talk that was given at the Trieste Symposium. Am I correct?
Yeah.
Okay. So Andres, this third point, this third bullet point that is in your slide, in which you talk about the Planck length level And I would like to ask you, are you quoting, so is Wheeler that writes, where the geometry of space gets constantly made and unmade due to fluctuations, in the same way collapse makes geometry? So I would like to learn more about this passage of the paper, actually,
Yes,
because
sure.
it's very intriguing for us. Yeah, so this is my first question.
Okay, so let me first specify that this part was some sort of extra with respect to the paper on analogies. I just alluded to these things in there, but if you want a detailed reconstruction, it is in the paper that I wrote with Alexander Bloom. I can send it to you since, well, it's going to be published soon, but we don't know when. So the basic idea, as you can see also from the title of this paper, somehow ironical, but of course the point is about the genesis of Wheeler's idea of law without law. That is, there are no eternal laws or metaphysical laws that are in a sense imposed to the universe. Rather, there is just this sort of gradual self-organization of the universe itself with emerging regularities, right? And all these ideas, in a sense, are intertwined with other considerations that I alluded to, such as this dialogue with Prigogine, other inspiration from biophysics, his renewed meditation during the 70s on the role of the observer, on Bohr's lesson, and so on. But there is, in the midst of all these intertwined concepts, a sort of way of streamlining these considerations. And that is what we did in the paper. That is to see how in the more or less 20 years in which Wheeler dedicated himself to general relativity / geometry dynamics, he reached these conclusions. So there are pages in the mid-60s from Wheeler's notebooks in which he started considering, well, of course, everything is geometry and so on, but when he introduced that superspace arena, in which each point represents a possible geometry of the universe, he realizes that more than everything is geometry, in the sense that it is geometrodynamical laws, in a sense, are not just describing our actual universe, but in a sense are a proto-multiverse, because then you are considering all these different possibilities, and not just as, let's say, contemplative or passive possibilities, but as actual virtualities, in the sense that because of quantum foam and these interferences between different possible geometries, they give actual contributions even to our own universe. So in this sense, they are virtualities rather than just contemplative possibilities. And then there were those problems I alluded to, that is, he wanted to use this arena of this superspace of quantum geometry dynamics to capture this guiding idea of quantum foam with these topology changes and so on, which were also linked to the idea of geometrizing the spin of elementary particles. And there were no mathematical progresses in this direction. So by the end of the 60s, somehow Wheeler realizes that, sure, only the work he did on geometry dynamics, on systematizing general relativity, and so on, is of course valuable, but it could not be the last word. It could not be a fundamental level. And then there is this other order of considerations that explains the mutability of the title. That is, all these considerations were triggered, in a sense, by his problematic engagement with the black hole. In the sense that in '58, Solvay conference, we find Wheeler that is opposing explicitly Oppenheimer and Snyder's results 20 years earlier, 19 years earlier. And 9 years later, we find Wheeler that is enthusiastically baptizing black holes and trying to spread them not just as a an interesting, fascinating, exotic astrophysical entity, but as a window on the genesis and perhaps the end of the universe itself, right? And so the way he approached at first these questions, and the reasons why he was very skeptical about Oppenheimer and Snyder's continued collapse, was that Wheeler, coming from a nuclear physicist background, was thinking in terms of matter. That is, he was considering what happens to the law of the conservation of baryons, of let's say, to the number of particles when they get over-compressed in the black hole region. And he somehow made a lot of speculations. He even postulated some delta rays that, of course, he then rejected. But his idea, already in the late 50s, was that the conservation of baryonic number, the number of the nuclei particles, gets not just violated in the sense that we are saying that some conservation of parity, for instance, gets violated, but gets transcended in the sense that within the horizon of the black hole, there is no way of assessing whether this number is conserved or violated. It just loses any meaning. So in this sense, he started to think that in extreme enough situations, all kind of physical laws would get transcended until, well, he has this quite funny picture of the ladder of physics, the staircase of physics, right? When you are going in extreme situations, in a sense, you take another step. What you thought that it was a fundamental law was actually just a local regularity. And in the end, well, one had to dig deeper and try to understand this pre-geometrical level, the deep reason for quantum physics, and so on. And then he generalized his idea about the transcendence of the law of the conservation of baryonic number to all physical laws. So in this sense, that's the mutability. But the thing is, since the black hole was a consequence of general relativity, he saw this mutability as the last prediction of general relativity in a sense. But this general relativity was at the same time indicating some new important unexpected result, which also marked its own limitations. And this got intertwined with, of course, this idea of everything is geometry. In the black hole, geometry itself, the geometry of space gets turned apart in a sense. So geometry cannot be the most fundamental level. And yes, in this sense, quantum foam becomes the manifestation, because of this change of geometry / change of laws, of this lawlessness that is pervading all the universe, in the sense that those are not given from eternity to eternity, but are just something gradually assembling itself, so to speak.
Yeah, even if I must add a remark to what you just said, the fact that our mathematics or our physics is not able to tell us exactly what's going on at a certain fundamental level doesn't mean that, you know, we know or we can identify what happens at that fundamental level, but this is just, you know.
Yeah, of course. I mean, there's a reason in the same years, Misner, who had been his long collaborators in geometry dynamics, takes his distance and makes a distinction between physical or mathematical geometry dynamics. And then he says there is this visionary geometry dynamics that is just Wheeler's things. So in a sense, other physicists perceived very well that all this was a somehow wild speculation. But at the same time, for all this analogical means and his way of communicating, Wheeler was always able to bring in new collaborators and trying to develop these ideas. Even, of course, well, that's why they are so interesting. At least that's the reason why I'm interested in them, in the sense that I think it's really one of the crucial beginnings or roots of the situation in non-empirical speculations in today's physics, especially in these questions that Wheeler himself somehow brought up for the first time.
Well, indeed, it's actually, well, this I think you quoted from the paper. The question is physics legislated by cosmogony. Yeah. So it's clear that, I mean, I can only, but I agree with this, you know, with this remark, with this question. And I think also that you touched, I mean, Wheeler touched, but you of course touched by talking about his work. You touched a very profound question with several implications. I mean, at the philosophical level, but also at existential level, because of course, then we have to ask the question of the necessary contingency or the contingent necessity of the world. We must be able to produce suitable categories to say why it is, or to what extent it is contingent. And so our lives are contingent. And it's not at all necessary that we live in the world we live in. So these are huge questions. There will be always questions like this, and they pertain to the realm of philosophy, maybe of anthropology, to a certain extent.
But if we may add just one thing, since I'm also talking to philosophers and so on, I guess, well, of course, Wheeler himself perceived that these questions had a very long story, and in a sense, he was also making questions about his questions. He was not pretending to have reached the answer, right? And that is why he looked for confrontations with people from other areas, such as Manfred Eigen, or there is also, well, he tried to establish a dialogue with Paul Cohen, the famous logician mathematician, with Gödel, with Max Delbruck, and so on. And not only that, in a sense that he always had this idea of science as conviviality, this idea of having a constant dialogue also with people from other disciplines and so on. But then he has also this quite curious notion, at least how he phrased it, that is intracranial colleagues. And, so by that he meant that some figures that he had met in the past decades, such as Einstein and Bohr, but also people from past ages, could become, in a sense, an interiorized figure, which could offer him a sort of a dialogical pole. And it is in this way that he started to get interested in ancient modern philosophy, especially in Leibniz, but not only, as I said. And I think, so we have to keep in mind that Wheeler, as a background, did not have the kind of, let's say, gymnasium education that Heisenberg or Schrödinger had. Wheeler had just a very technical education, and somehow got acquainted with this big name of the philosophical tradition through dialogues with people like, of course, Einstein, Bohr, Weil, and so on. And then we see that when he reaches the age of 60s, more or less, he has all these big questions on the table, and he starts to find analogies with the way these people try to answer these questions. But in a sense, he doesn't take philologically some answer and try to repeat or actualize it in his own physics, but rather he perceived as a sort of a fellow seeker that in a past stage in front of a similar constellation of problems tried to offer an answer, approaching the way in a certain, according to a certain direction, and then he used it as a sort of dialogical pole of confrontation / inspiration. So I think that that's also quite interesting as a way to frame these relations between physics and philosophy, or at least history of physics and history of philosophy.
Okay, thank you. Before going ahead, are there people who want to, is there someone who wants to ask questions or comments, clarification? No? Okay, so I have another comment on Rocco's presentation. So let's say the first part of the talk. So it concerns, I mean, your observations on the current status of the debate on analogy and analogical reasoning. And I think that you said something extremely important in the sense that, I mean, you emphasized on the one hand the limits of the current debate on analogical reasoning, but also the fact that there is an irreducible limit when we talk about analogy. If we consider analogy in terms of the outcome, that so and indeed generally I absolutely endorse your observation and your criticism, because of course when we talk about analogical reasoning, we're talking about a process, we're talking about the making of the analogy. While when we talk about analogies, well, there might well be outcomes, you know, it's just the final product of a certain dynamical process that produces the analogy in the end. And it's very intriguing, especially from the, so my question basically reduces at this. Do you think that, so philosophers, especially, let's say, analytic philosophers they do have this tendency not to consider or clearly to distinguish the procedure giving rise to the analogy and the product itself as an outcome, which is rather useful for the historian of science, especially the historian of physics or the historian of biology, because when we do science, I say we because sometimes I do science, but in the sense we use analogy partly because it helps us in clarifying to us what we are observing or what we want to talk about, and we say, oh, we might try to do in the same way as we do for the other phenomenon. We could try to use the same or almost the same concepts in order to describe more or less what's not really clear yet. On the other hand, as you recalled, one can use analogy better, analogical reasoning in heuristic terms, and it is precisely what, in most of the cases in the sciences, we find when we talk about analogy. So my question is basically, is it possible, or do you think you want to work more on it maybe in the future? Is it possible to spell out an inception of analogical reasoning that is not just more helpful to capture what scientists do, but also that is much more helpful for us also in doing history of science, because it's clear that the current debates in analytic philosophy regarding analogy are not at all able to reconstruct the picture, you know, concerning also historical examples in which analogies played a fundamental role in spelling out theories, in spelling out experiments, and so on.
So you're asking whether, so we in a sense we are trying to kind of provide these tools. I mean, of course, it's always somewhat limiting, but the few points that I offered, of course, that there would be more even, but they would serve a kind of guidance for someone who wants to kind of, when reading both the philosophical analogies, so analogies that are treated in philosophy, or approaching himself or herself a historical case, would like to kind of use as abstract enough, but also close enough to the practices. So the idea is to kind of offer a framework that is not as abstract and somehow as often the philosophical one, which focuses on just very few points of a large picture, in a sense, you know, and the one who is, in a sense, the level of science itself, that is so somewhere in between, you know, in which we can offer some kind of framework for understanding how analogy can play a role in the discovery process, but are enough connected and rooted in the cases themselves. Because I mean, of course, the point of most of the philosophical the philosophy of science, so the reasoning, the discourse about science in a philosophical way, is that it tends to be too much on the, I guess, on the level up, rather, and doesn't want to kind of immerse itself into the practices. So in a sense, I mean, this would provide a middle way, let's say, you know. So ideally, I would say also perhaps not only for the philosopher, not only for the historian, but for the scientists themselves, because in a sense, it takes also sometimes some courage and some I mean, something in order to make some steps, you know, heuristic steps that are rather bold, but in fact they can turn out to be very successful after all. I mean, or take someone on a path that is unexpected. I mean, so I don't know. It does as a work, the one that I've started with Nambu and I'm elaborating, and then doing with Stefano, is to offer this kind of framework, and also on the other direction, to try to show that there is not much difference between an artistic and a scientific type of creativity. So I mean, in a sense, you know, kind of as different purposes. On the one hand, to enrich the philosophical part; on the other, to show some kind of similarities between the when it comes to the heuristics, to the creation, to the creation, the creativity, to show the similarity between the science and some more of a artistic type of framework. So as several purposes, I would say. One thing that I would say, so perhaps is that there is this thing about if one doesn't, I think one of the main drawbacks of the philosophical accounts of analogy is precisely the fact that I mean, again, focusing on the outcome, you don't consider the fact that there can be intermediate, that this outcome can be really like one of the main steps in the process. So, you know, that's again, so some of the things that you some of the limits is precisely the fact that an argumentation that does not really engage with the practices is not able to recognize intermediate from final steps, and again judges things in a way that are not in fact really the way should be judged. Because if I go to a theatrical representation or to a mime representation, and I cannot say that this is that a representation is false or true, but I rather say whether it did convey a certain meaning, whether it did take me somewhere, rather than again whether it's false or true. So I'm trying to kind of establish this twist in the way we look at the context of discovery, you know, and analogical reasoning in particular. I don't know if I answered you. Well,
yes. Actually, I think also that we have a follow-up by Nicola Bamonti and then Laura Maronjo.
Just what you just said about the context of discovery, and given this role of first of all, 3 questions. When you speak about analogy, you
said just a follow-up, Nicola.
You
3 questions. A follow-up with 3 questions.
Three-folded.
Visualization or also mathematical analogy, first of all, and then you're saying that analogy is relevant in the context of discovery.
Yeah.
And I would ask you if you think that it's also important in the context of justification of a theory by an analogy, for example. Yeah, the follow-up was that given this role of analogy, how do you see the relation with the question about realism? So if you are dealing with a theory in the context of analogy, and you're saying, I don't care if it's true or false. So how do you relate this vision with the realism? So that is the question.
Yeah. So, wait, your first point is repeat me again that I didn't.
Yeah, if you mean when you talk about analogy, if you mean something related to visualization, so visualization
yes.
theory, or also mathematical analogy. So I treat this theory with a mathematical analogy of another theory that I know.
Yeah. Well, no, I mean, these are of course quite complicated questions. But so let's say, in a sense, I would say both, in the sense that analogies have both a visual, can have a more visual character. They help you to understand or actually really used so to transport a relation between some manifestations in one domain to another. So basically that you use truly the relation that you establish in a domain between the phenomena, and you do then really kind of try to transport or use that as a blueprint to see whether that connection is present in the domain that you don't know of. So this was the case of Nambu, for example, where, I mean, the case I said, where you kind of see that in superconductors there is a phenomenon that there is a relation between the manifestations that actually also is in the vacuum itself. So in another completely different structure at a different dimension. So for example, you can go across scales, I mean, between one scale and another scale in terms of energy and size by using this formal bridge that with one, you use this blueprint to look at the other one, and you do find that in fact there is a same type of relation between the entities in completely another domain, for example. So I mean, this would speak more to the formal part, so to the mathematical analogies, but there is also a lot of visualization, in the sense that I don't know, perhaps the visualization is more so again, perhaps the visualization is the following. So I spoke about so of course analogies can be between, they can be, say, two different contexts that are, say, abstract, equally abstract, or one, but most often is actually a combination of an abstract concept and a concrete. So there is a concrete and an abstract domain. So in a sense, you use the concreteness of one to formulate where, something in a more abstract domain that would be more difficult to formulate. So there is a strong component of visualization there, in the sense that it is not just a transporting of one thing or the other, but it actually a vehicle for you to have a concrete correlate of something that is very hard to capture otherwise. So I just maybe give you an example again related to the historical case that I talked about. And so in a sense, you can look at what happened with Nambu and with this spontaneous symmetry breaking phenomena that was discovered in the vacuum of the universe, is the fact that the superconductor did play as a scale model of, if you wish, of the universe itself, because what you're doing is transferring certain phenomena in superconductor to the universe at large. So in a sense, again, the superconductor did serve to actually, I mean, perhaps it gets a little bit complicated here, but I would say not only to provide a mathematical framework that then you transported there, but really to kind of produce a scale, like a scale of something, a scale model. And the scale model is something that you can manipulate So of course, I mean, your question is more about visualization, but perhaps would need to be specified. What I can tell you is that certainly there are cases in which you actually use something that you can manipulate, that is closer to you, it is more concrete, that you can experiment on and play on, then you transfer it to something that is otherwise, that is somewhere very abstract, that you cannot really even touch or manipulate. So I don't know if this kind of addresses your question. The problem, I guess, in your question is that visualization is a little bit of a problematic. I mean, it's a very broad type of, so yeah, I don't know if the concrete abstract thing answered your question in that sense.
Yeah, and also this kind of manipulation is also a problem. And I think that one example is the analog experiment of the black hole, yes. The thermodynamics of the black holes. With the analog, with I think something like fluidodynamics or something like that.
Exactly.
The question is, yeah, but you are dealing with two different sizes and energy scales, so it's really true the analog that you're dealing with while you're talking about black holes in. So that is another type of problematic question. If analogy is can give us some
in inference too,
no,
that in fact speaks, I guess, to your question about realism in a sense, no, or at least like from a certain perspective, I would say. So yeah, exactly. So this is what I try to be to complement. No, I try to complement exactly those reasonings in the philosophy of physics that say, I don't know, take that Bayesian perspective in order to say, okay, well, does analogy or like taking analogy as an inductive process? Okay, does analogy tell me really something about a black hole on which I cannot experiment on? If I do experiment here in the lab on a tabletop experiment, can this really be, can I really infer with some certainty, no, on what happens? Well, I mean, this is of course, it's not my, I haven't really investigated much of that. I mean, again, I try to offer some more of a complementary view. So my idea is that in a sense, one should be able to have another means of experimentation. So I don't think relying on analogy can give you ever some sort of real certainty about. I mean, in the lack of something else, of course, it does. But again, it illustrates, it gives you a direction, it gives you a blueprint, or rather than strictly proving. I mean, after all, it is always a form of induction. So, I mean, there can be some certainty because I don't know, there are 3 or 4 things that are the same, and then you are inferring on the one that you don't know or you cannot observe, and then you say, well, okay, well, this gives a certain strength to the argument and to the things that I don't observe because I observe the same structure here, and I can transfer it to the thing I don't observe. But I mean, I'm actually not much in favor of this of this kind of view that tries to see whether analogy can actually be used as a verification tool, and I think it's always good to try to find another, I mean, when possibly another means of verification, and that's what I try to say is also that in a sense, if you look at the historical cases, most of them have been, the analogies have been a thing that, a tool that you use to provide a model, to arrive at a model that then you verify independently, So, yeah, so I don't know if this, again, so this what your question about context of discovery and justification, in fact, is connected to that, whether no one can sort of find, well, is there really a connection? Yeah, I mean, I am not that much in favor of that, or yeah, and so there. I don't know if I answer or you have some try to answer in a way. So the relation with realism is of course something that, yeah, we go into a territory that I mean, it's I rather say it's more of our own opinions about it, because it's a whole matter whether analogies are there or we invent them, whether we do provide representation of phenomena or rather that we are really probing them in a real sense, like are really there, that our constructions, our models do reflect on a reality that is there. In a sense, the multiplicity of representations that you can give would play against this type of real. So no, if you say that certain things at certain times, so I mean, no, so our evidence or our when you take a certain representation or do a certain model, and then other things are revealed when you take another perspective on things, like as if you were saying, from a single object I can really extract different things, and sometimes I use this again an analogy to illustrate how analogy works, and it goes that basically say when you're trying to spot a resemblance between two people and two faces that are relative to each other, no? So I don't know, a parent and a daughter or so on, and everyone will come out with an angle. We will say, okay, well, it resembles you, it resembles the father, it resembles the mother, or I see it here or that side in the same person. So I think that the representation, in a sense, that analogy gives of reality, it is a similar thing. So sometimes you reveal certain aspects, some other times you reveal other aspects, and so it would, in fact, speak to the fact that we are rather imposing structures, to understand the phenomena, rather than the phenomena being just uniquely there in one single way, So I guess, this is what I can say from the perspective of analogy. What is the result on realism,
Okay, thank you.
Yeah, you're welcome. I hope I was just not too confused. Yeah.
So Laura Marondo.
So thank you. It was very interesting. So first of all, I'm not an historian of physics, but an historian of ancient philosophy. So sorry in advance if my question sounds a bit weird.
Right.
I have a small commentary and a question also regarding the first part of the presentation, and in particular, the distinction between analogy on the one hand and metaphor on the other hand.
Yeah.
So first, the commentary. So I found it very, very interesting. So that in your description of analogy, so there are very, very many resemblances to Plato's definition of example. So in the dialogues, in the statement. Mm-hmm. So he says too that the paradigm, which can be understood as an example, is also introduced to illuminate something which is particularly difficult, but it also says, so we can use it as a tool which has an heuristic function. Through example, we can gain knowledge, and also another point was interesting. So you also said that the analogy brings us from a state of disorientation, so to say, to a condition where we can at least look an object from a specific point of view or perspective. And yeah, we can say Plato says something similar, even though in strange terms. So he says that, yeah, through example, we can go from a dreaming state and then wake up if we use them so correctly. And so my question would be, since Plato in most cases doesn't really distinguish sharply between images, examples, models, or analogies, so they are a little bit mixed up altogether.
Yeah.
I was just curious to hear a little bit more on how you frame this distinction between so analogy and metaphor.
Yeah. It's a good question, actually. Also, the tips that you gave. I mean, you could say briefly that metaphor is a sort of an implicit analogy, if you wish, in the sense that it's up to you to figure out what are the representative characters, the representative features of the object that you juxtapose to each other, and so say yes, if I say you are a wolf, or I don't know, you are like a lion, or something like this. So you use this kind of read descriptions of a person, well, in a sense, you let the receiver to figure out what is that this is meant. So whereas an analogy is actually, in the simplest, is really a proportion. So you are stating that you know, that quality of yours is to you like that other quality of the thing is to the thing, you know. So it is really like something that specifies in which direction precisely you are actually you want the person to receive that, no? So yeah, so I guess this would be one way of looking at it. So that's why, in a sense, analogy is if you wish, in a heuristic context in science, analogy is preferable or is more used as actually as a tool to go about something, to kind of or illustrate something, because it is more specific about what it is to be compared. And also, again, there is a kind of a mathematical counterpart to that, because in a sense it is formulable in terms of a proportion between terms, you know. It is so I think, yeah, so that's in a sense, analogy gives you, so it is in a sense, you know, if you wish, a proportion is made by a ratio on one side, which is equal to a ratio on the other side, and so what it expresses is a conserved quantity, what is conserved is a ratio between two things. So it is can be actually very precise what it is, you know. So that's kind of I would say what distinguishes them, you know. Yeah.
Thank you.
You're welcome.
Other issues, questions, comments? No? Okay, so let's thank our speakers again. And thank you, Rocco. Thank you, Stefano. It was really intriguing. And as you see, you simulated the discussion. And I also would like to thank Laura and Nicola for the questions, for being here today. And say bye to the rest of the group. I'll see you next week.
Yeah.
So
thank you very much.
Good luck for the publication of your joint work. I'm sure that it'll be good. Everything will be fine. Thank you very much again for being here. So
thank you.
Thank you.
Bye all.
Bye.
Bye.
Bye.